Recording in progress.
Okay. Hi, everyone. Good morning. I hope everyone is doing great. Can someone quickly send me the part test 3 question paper to my WhatsApp? Quickly. Anyone? Please send me. Please WhatsApp me a question paper for part test 3. Mithun, can you do it? Can you send me the question paper? Mithun?
Sir, check the WhatsApp, sir. I sent, sir.
You sent? Oh, great. Just give me a moment, people. I'll just download the paper and I'll put it here. Well, okay, I got it. Let me share my screen and then we'll straight away start. Okay. We have a lot of questions. We'll quickly do this. Okay. Now, which of the following depicts the oxidizing behavior of H2SO4? Right. So basically, what you have to understand is the H2SO4 is going to act as an oxidizing agent. In which case is that's what they're asking. Okay. Now all you have to look for is your oxidation numbers. Now you see for calcium it is +2 here. Here also for calcium it is +2 and no oxidation state is changing. For sulfur it will be +6, right? Here also for sulfur it is +6. Everywhere if you calculate, right, the oxidation numbers are not changing. Same goes here. Here the phosphorus is in +5 oxidation state. Here also sulfur, phosphorus will be +5 oxidation state. Even sulfur in this case will be +6, and in this case also +6. So B also cannot be the answer, right? You need to have change in oxidation states for oxidation or reduction to happen, right? Okay, next, Na. Now look at this. Na is in +1 oxidation state. Na is in +1 oxidation state. H2SO4, sulfur is in +6. In this case also, sulfur is in +6 oxidation state. Okay, so again, you see that nothing is changing. So this cannot be the answer. But you look at this compound, Hi, right? I minus, right? This is -1 oxidation state for iodine, right? And here you see iodine is in what oxidation state? Can someone quickly, tell me what is the oxidation state of iodine I2? What is the oxidation state? Quickly tell me, what is the oxidation state of iodine in I2? What is the oxidation state?
-2.
Look at this, people. Whenever you have elements in their free state, okay, what do you mean by free state? How they are available in nature, right? For all the elements existing in their natural state or free state, the oxidation state is 0. Okay, the oxidation state is 0. Okay, for example, if I write H2, if I ask you what is the oxidation state of hydrogen in H2, it is 0. For I2, the iodine is 0. Say for sodium, if I have only sodium solid, this is how it exists in nature. Again, the oxidation state is 0. Okay, this you have to remember. So in this case, you see -1 is becoming 0. Okay, -1 in the reactant state, in the reactant side for iodine is becoming 0, right? So definitely what is happening? Increase in oxidation number. Increase in oxidation number is oxidation, right? Same way, decrease in oxidation number is reduction, right? So -1 to 0, iodine is getting oxidized, and obviously sulfur, if you check, sulfur in this case will be +6, right? And in SO2, sulfur will be in +4 oxidation state. Okay, sulfur will be in +6, and in this case will be +4 oxidation state. So this is reduction, right? And I know whichever is undergoing reduction is my oxidizing agent. So definitely H2SO4 is undergoing reduction. So it is my oxidizing agent. Whichever undergoes reduction is my oxidizing agent. Whichever undergoes oxidation is reducing agent. Ulta, right? So iodine is getting oxidized, and which is oxidizing it? H2SO4. So the correct answer would be option D. Okay, I hope you got the answer. I hope how we do this is very simple. All you have to do is just check for the oxidation states. Okay, fine. Next, second question. Affinity for hydrogen, right? Affinity for hydrogen decreases down the group. That's what they're telling. Decreases from fluorine to iodine. That is, when I go down the group, affinity for hydrogen decreases, right? Which of the following acids have the highest bond dissociation enthalpy? Right, now you understand that affinity for hydrogen, right? How they can attract the hydrogen decreases down the group. That is, fluorine has the highest affinity for hydrogen. So if I have a HF bond, that would be the strongest bond, right? And HI, if I have the HI down the group, what happens? The affinity for hydrogen decreases. So HI will be the weakest bond, right? So the correct answer to this question, which has the highest bond dissociation enthalpy, the stronger bond will have higher bond dissociation enthalpy. So the answer to this question is HF. Right. Next, when chlorine is passed through a solution of concentrated KOH, we have already seen this, right? And instead of KOH, we have seen NaOH. That's the only difference here. So if I have chlorine reacting with NaOH concentrated, what are the products formed? Quickly tell me. I know dilute will have something else, right? Concentrated will have something else. What is that? What will come here? Concentrated. We even solved this question in the quiz, if you can remember. What is the product? Okay, so it is NaCl and NaClO3. Okay, NaClO3, NaOCl3, NaOCl3, whatever it is, NaOCl3. Okay, fine. So that is what is the product. So in this case, it is potassium. So potassium would have been KClO3. Okay, NaClO3 is there, right? If it was dilute, what would have happened, people? Cl2 plus NaOH dilute, right, would have formed NaCl plus NaOCl. Okay, only one oxygen here. Here it is 3 oxygens. That is the only difference between concentrated and dilute. Okay, so the answer to this question is KClO3. That is NaClO3, but there is in KOH here, so it is KClO3. That's the only difference. Okay, fine. Next, which among the following hydrides are most acidic? Right, now please understand, people. Say if I have a H bond, this H plus has to come out for H plus, right? So what you have to understand is I have to break this bond. Any acid, if you have, I have to break the hydrogen from the other atom, right? I have to break the bond. So what you have to understand is acidic strength, right, is inversely proportional to the bond enthalpy or bond energy. We'll write bond enthalpy. Okay, easier to break the bond. If you can supply less energy and break the bond, that becomes a better acid. Okay, that is why we write acidic strength and bond destruction enthalpy are inversely related, right? A weaker bond can, with amount of less amount of energy spent itself, we will be able to break the bond, so that becomes a stronger acid, right? And I know when I go down the group, right? When I go down the group, affinity for hydrogen decreases. We saw in last question also. Affinity for hydrogen decreases. Why? Because electronegativity decreases. Okay, electronegativity decreases. So now you see what are all the elements present: sulfur, selenium, tellurium, oxygen, right? So if you remember the group, what exactly it is oxygen, sulfur, selenium, tellurium. These are all the things. So obviously H2Te, right? TeH bond, right? TeH bond is the weakest, right? So here I have to supply the least amount of energy for H plus to come out. So the answer to this question is H2Te, right? Which can easily give me H plus. H2Te can easily give me H plus. I know OH bond is very strong. SH bond is little stronger. Selenium H bond is also a little stronger. Weakest of them all is H2Te. Okay, fine. Next, bleaching powder. Bleaching powder is treated with CO2. What and all will be formed? I think you'll be able to easily get the answer, people. CaO, Cl twice plus CO2 will give me CaCO3 plus Cl2 gas will be plus Cl2 will be a what, right? So the answer to this question is option D. Okay, next. The correct order of thermal stability of H2E and E can be sulfur, oxygen, sulfur, selenium, tellurium, and polonium. Okay, now just now we saw thermal stability. If they ask you about thermal stability, right, that is again directly proportional to the bond energy or the bond enthalpy. Stronger bond means very stable, right? When I have a very strong bond, that means it is very stable. Okay, so now we know, we already saw in the previous question that when I go down the group, the bond energy decreases, right? H2O, OH bond is the strongest, and tellurium was the weakest. In this case, polonium would have been the weakest, right? So polonium should be the least stable. H2PO should be the least stable, and H2O should be maximum stable because of the higher bond enthalpy, right? So the answer to this question is option D, right? Next. Question number 7. You have to do the shapes, right? That's what you have to do for all these compounds, XCF4, XCF6, all these compounds. You have to find what is the shape of this. Okay, right. Now we'll do it. Okay, first we have XCF4. Right. Now XCF4 belongs to the category of AB4L2. Now what do you mean by AB4L2? A is the central atom, right? B is the bonding atom. L is the lone pair. Okay, A is the central atom, B is the bonding atom, L is the lone pair. Now you see, xenon has 8 valence electrons. Okay, xenon has 8 valence electrons. 4 of the electrons are involved in bonding. Okay, with fluorine. Okay, out of 8 valence electrons, 4 are involving in bonding, right? So obviously, how many electrons are left out? These are valence electrons, not the total electrons, people. These are valence electrons. Out of these 8 valence electrons, 4 are involved in bonding with fluorine, right? So what is left out is another 4 electrons. These 4 electrons will be in the form of 2 lone pairs, right? 1 pair means 2 electrons, right? So 4 electrons means 2 lone pairs. Okay, so the moment you see AB4L2, right? So you must know that it is going to be square planar. Okay, now forget about this. The moment you see, I think you have to know something called as a steric number. Okay, steric number is equal to, again, if you know the steric number, you know the hybridization. Okay, the steric number is equal to number of atoms bonded to the central atom plus the number of lone pairs in the central atom. Okay, so you have to take into account of how many atoms are bonded to the central atom and how many lone pairs are there in the central atom. Now, if you can check for XeF4, Xe, right? I'm talking about the steric number for Xe in XeF4, right? Now you see that there are 4 bonding atoms, right? 4 fluorine atoms, right? And just now we checked that it has 2 lone pairs, so it is 6. Okay, the moment you find it is 6, I know it is going to be sp3d2. If, for example, if steric number is 2, it is sp, 3 means sp2, 4 means sp3, 5 means sp3d, and 6 means sp3d2. Okay, the moment you see sp3d2 or steric number 6, I can tell the geometry, right? Geometry is octahedral, right? Okay, geometry is octahedral. Octahedral will be like this. Basically, if I have A, B, 6 kind of molecules, this is how it will be, right? All are 90 degrees, all bond same, right? This is my octahedral shape. Okay, now what I have to do, this is not AB6, right? XeF4 is not AB6, but it is AB4L2, right? I have 2 lone pairs here. Not all are bonding atoms, but I have 2 lone pairs. So what you have to do is you have to accommodate 2 lone pairs. So what can you do is remove the opposite B's, right? Whichever you can remove the opposite B's. Okay, and you include a lone pair. Okay, now forget that these 2 are there. Now, if you forget that these lone pairs are there, you will end up with this one, right? And this you can see is square planar. Okay, and that's exactly what is happening with XeF4. Okay, this is square planar. Okay, so XeF4 is going to be square planar. Okay, so XeF4A goes with square planar, that is 2. Okay, 3. Sorry, A is 2. Okay, see where I have A2, A2, A2. Okay, so B and C, or sorry, C, B and D can only be answers because A and B are different. I think it's option C, I guess this is. Okay, right. Anyways, right. Next, XeF6. Now, again, you have to do the same thing, people. XeF6. Okay, now I know this has 8 valence electrons. 8 valence electrons, 6 are involved in bonding with fluorine. So 2 electrons are left out. So 1 lone pair. Okay, if you calculate the steric number for this would be 6. That is number of bonding atoms. Number of bonding atoms is 6. And how many lone pairs? The number of lone pairs is 1. So totally 7. Okay, now if at all, if you have AB7, that is when you have 7 bonding atoms, the geometry will be pentagonal bipyramidal. Right, pentagonal bipyramidal if I have AB7. Okay, pentagonal bipyramidal will be like this. A, now draw a pentagon. Okay, and you put 2 pyramids, one at the top, one at the bottom. All the corners you are going to have B. Okay, something like this. Okay, pentagon with 2 pyramids. Okay, now what happens is I don't have AB7, but I have AB6L. That means 6 bonding atoms in the form of fluorine and 1 lone pair we calculated. Okay, so now this structure will now change to a complicated structure. When you have AB6L, this is going to be called as distorted octahedral shape. Distorted octahedral, because when I have AB6 people, just now we saw in previous case. Okay, when I have AB6, okay, this is fine. This is octahedral. Now, somewhere, if I put a lone pair, right, this entire structure gets distorted. Okay, this entire structure gets distorted. So that is why we call it as distorted octahedral. Right? So obviously, B, that is XCF6, would have been distorted octahedral. That is B is 3. Where is B is 3? Okay, B is 3. B is 3. So again, we cannot choose. Okay, next, XCOF4. Right? Now. Okay, XCOF4. Now you see again, this has 8 valence electrons. 2 electrons will go for oxygen, because I know oxygen forms double bonds. Okay, oxygen forms double bonds, so 2 electrons will go, and 4 fluorine atoms, so each 1 electron. So totally again it is 6. Right? Sorry. 8 minus. This is 6. So total 2 electrons are left out. So 1 lone pair. Okay, 1 lone pair on nitrogen. I mean, now 1 lone pair on xenon. Right? Now, which category it will come into? Now I have 5 bonding atoms, 1 oxygen, 4 fluorines. So AB5 and 1 lone pair, AB5L. Right? Now again, you see the steric number is 6. Right? 5 bonding atoms and 1 lone pair. 5 plus 1 will become 6. Right? So the moment if you have steric number 6, the geometry is octahedral. Right? Geometry is octahedral. Now octahedral, I know how it will look. B, 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 and B. Right? Now what are you doing? It is not AB6, it is AB6L. So you will just replace one of the bonding atoms with a lone pair. Right? One of the bonding atoms with a lone pair. Now forget that this is there. Okay? I can write it like this. Right? A, B, 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 5 B's and 1 lone pair, which I'm not writing at all. Okay, now can you see that this is a square, right? And here you have a pyramid. Okay, this is a square, right? 4 B's and 1 B is in the form of a pyramid, right? So this is square pyramid, right? And that's exactly what is happening for XCOF4 also. If I can draw the proper structure, this is how it will be, people. XC double bond O, F, 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 and F. This is how the structure would be, a square with a pyramid on the top, right? So XCOF4 will be square pyramidal. Okay, where is it? So C is 4. Where is C4? Yeah, C4 is here, right? So the correct answer would be C. We'll check for D also. Okay, XCO3. Now you check. XCO3, this has 8 valence electrons. Okay, and I say 6 electrons are going with oxygen. For 1 oxygen, 2 electrons, because it forms a double bond, right? So now again 2 electrons are left out, so that means 1 lone pair, right? So now this belongs to category of what? AB3. Okay, that is 3 bonding atoms, and I found it as 1 lone pair, right? So the steric number is 4, right? 3 bonding atoms and 1 lone pair. Steric number 4. Steric number 4 means sp3 hybridized. Anyways, now if it is going to be AB4, it would have been tetrahedral. Okay, this would have been tetrahedral if it was AB4. Okay, but it is not. So this is how it will be. Okay, 3 bonding atoms and 1 lone pair. Now this kind of structures, AB3L, these kind of structures are what are called as pyramidal structures. Okay, the shape, I mean geometry or shape is what is called as pyramidal. So this is how exactly how your XCO3 will also be there. Okay, so this is my pyramidal shape. Okay, so definitely my XCO3 would have been pyramidal, that is D is 1. Yes, D is 1. So the correct answer to this question is option C. Okay, next. Which of the following forms 3 series of salts? That is, you have to form 3 salts. Now, if you want to form 3 salts, right, I need to have 3H plus. I need to have 3H plus, which can be displaced from the acid. Okay, now I think you would all guess the answer. What is this? The answer is H3PO4. Now, please understand, number of H plus is equal to number of OH bonds in the acid. Right? Number of OH bonds in the acid. So if you check for H3PO4, P double bond O, OH, OH, OH. This would have been the structure for H3PO4. Okay, now you see the 3 OH are there, 3 OH bonds are there. So 3 H plus can come out, right? And these 3 H plus can come out. Look at this, right? See, H3PO4, for example, say I make it react with 1 NaOH. What will you form is NaH2PO4. Now you understand how am I writing this, right? So basically I remove the H plus from this, right? If I remove a H plus from this, what is remaining? H2PO4 minus, okay? H2PO4 minus and Na plus. This is my first salt, right? Now again I can do, again one more NaOH. If I add, right? Now again one more hydrogen will be replaced. So you will form NaHPO4, Na2HPO4. Right? Now one more, this is the second salt, and one more time NaOH. If you add, there's still one more hydrogen left out, right? So you can form Na3PO4. That's exactly is my sodium phosphate. Okay, this is my third salt. Okay, so definitely no other acid will be capable of doing this, because all of them say, if you check for H3PO3, it has only 2 OH bonds, right? HPO3 is entirely different. Forget about it, right? H3PO2 will have only 1 OH bond. Okay, so the correct answer, if you want to form 3 salts, definitely I need to have 3 OH plus. So that is happening in H3PO4. That is option C. Okay, next. Pure chlorine is obtained by what? Okay, pure chlorine is obtained by which one? Right, these are not theory questions, right? I think if you look into your textbooks, I think you'll be able to look at the answers. What is the answer given to this question in the
heating PTCl4, sir?
Heating PTCl4. Okay, see, I am not going to, like, these kind of questions are very rare. Okay, these kind of theoretical questions are very rare, but they can be asked. Okay, don't worry much about it, right? 1 question, 2 question like this, if it comes and you're not able to answer, completely all right. Okay, even I don't know this, right? How much will you remember? It's completely all right. Okay, so the answer would be whatever they have given you, that is heating PTCl4. Forget about it. Next. How many moles of oxygen are obtained by 8 moles of potassium chlorate? Okay, now potassium chlorate, if you don't know the formula, you are again done. This is KClO3. Okay. Excuse me. Right, okay, so KClO3. Okay, KClO3, right, on heating will give me KCl plus O2. Correct? Right? I mean, I have to write it properly. This is KClO3. Okay, so KClO3, potassium chloride on heating is giving me KCl plus O2. Now let me balance this. Okay, so if I have to balance this, if I put a 2 here and 2 here, oxygen becomes 6. So this is what I have. Okay, so what do you understand from the stoichiometry? 2 moles of KClO3 gives me, I'm talking about oxygen now because that is what is asked in the question, 2 moles stoichiometric coefficient, right? 2 moles of KClO3 is giving me 3 moles of O2, right? Now what are they asking? If I have 8 moles, if I have 8 moles of potassium chlorate, 8 if I have, what will be the number here? Right, now I think you have to learn it in your 11th class, stoichiometry, cross multiply, people, right? So it will be 2x, right? 2 into x is equal to 8 into 3, which is 24. Okay, so what should be the X value? X value should be 12 moles is the answer to this question. Very simple. Simple stoichiometry. All you have to know is what is potassium chloride. Potassium chloride in heating gives me what product, and then the stoichiometry. Very simple. 2 moles gives me 3 moles. So 8 moles will give me 8 moles will give me 12 moles. As simple as that. Right? So the answer to this question would be option D, 12. Fine. Moving on. Which of the following is not true for halogens? Okay. All form monobasic oxy acids. Okay. What do you mean by, first of all, monobasic? Can someone tell me what do you mean by monobasic? What is monobasic, people? Nobody knows what is monobasic. See, look at this. When I say basicity, okay, basic, one more right, okay, basicity, and there is something called as acidity. Okay, these are not the acidity when you have digestion problems, not that acidity. Okay, chemistry term. Okay, basicity is number of H plus an acid can give. Exactly ulta. Right? Basicity is number of H plus an acid can give. Acidity is number of OH minus a base can give. Exactly ulta pulta. Okay, basicity is number of H plus an acid can give. Acidity is number of OH minus the acid can give. Sorry, a base can give. Right. Okay. So now when I say a monobasic acid, now you can tell me what am I talking about? What do you mean by a monobasic acid, people? What is mono? What is mono in general?
One.
Very simple, right? Mono means one, right? Mono basic means basicity is what they're talking about. Can you tell me what exactly they're talking about here? That means what? Monobasic acid means what? Basicity, I told you, is number of H plus, right? So monobasic acid means what? This acid,
1 H plus.
This acid can give only 1 H plus. That is what they are telling. Okay, monobasic means only 1 H plus. Dibasic, I can write. Dibasic means 2 H plus. Tribasic, example for monobasic acid, say HCl. Dibasic acid, example H2SO4. Now I can even have a tribasic acid, right? Tribasic acid, and that would be my H3PO4 we just saw previously. Okay, these are all the terms which you have to know for answering simple questions like this. If you don't know what is basicity, if you don't know what do you mean by a monobasic acid, that your entire question is gone, right? This is very simple question, but because you don't know one word, gone. Right. Anyways, so where is it? All of the halogens form monobasic oxy acids. I think it is true, right? Right. See, for example, if I take chlorine, right? Chlorine, what are the oxy acids? HOCl, HOCl2, and HClO2, right? HClO3, HClO4. All these things are possible. Now you see that all of them has only one H associated with them. Right? All of them are having only one H associated with them. That means not only in the case of chlorine, even in bromine, iodine, whatever you see, right? There is only one H plus possible. Okay, so option A is correct. That means it is not a false statement; it is a true statement. Okay, next. Okay, fine. Next question is, next thing is all are oxidizing agents. Okay. Now, for oxidizing agent, for it to be oxidizing agent, the halogens has to undergo reduction, right? Okay, oxidizing agent means that has to undergo reduction in the particular reaction. Then only it can be oxidizing agent. Now look at this. Well, I don't know about any other thing. Now you see that F minus, if I have. Okay. Now can F minus become F2 easily? Is this possible? Now this is what is reduction, right? We're talking about reduction. Oh, this is oxidation actually. Okay, now we have to undergo reduction. So fluorine -1 oxidation state. Can I go to -2 or -3 oxidation state for fluorine? Is it possible? Did you understand my question, people? See, I'm talking about oxidizing agent. What oxidizing mean? What am I talking about? I'm talking about halogens. Okay, right. See, a better way of writing this is I have say Cl2, right? Can Cl2 become Cl minus or say F2? Can it become F minus? Possible, right? Definitely possible. Here, what is the oxidation state? 0. Here, what is the oxidation state? -1. Here, the oxidation state is 0. Here, the oxidation state is -1. So definitely this is reduction. Okay, that means all of them can undergo reduction very easily. Yes, right. And obviously, if they're undergoing reduction, all of them can be oxidizing agents. Okay, all of them can be oxidizing agent because all the halogens will be able to do this. They can undergo reduction to form their negative charges, right? Thereby, they're undergoing reduction and therefore they're oxidizing agents. Okay, but all halogens are oxidizing agents. Yes, I think proper. Yeah, even iodine can do this. Okay, I minus in iodine to I minus, that is also possible. Okay, next, all but fluorine shows positive oxidation states. Absolutely right. We have even solved some questions like this in your quiz. Okay, fluorine can form only one oxidation state, that is F minus, -1. But if you check for chlorine, if you check in the case of HClO3, whatever we show here, right? Chlorine here it is in +1, here it is in +3, +5, +7. All these structures are possible. All these oxidation states are possible. But for iodine, there is only one, that is -1. Okay, sorry, for fluorine, there is only one, that is -1. Okay, so this statement is also correct. All but fluorine shows positive oxidation state. Yes, absolutely right. Okay, next, chlorine has the highest electron gain enthalpy. Yes, right. Generally, we say when I go down the group, right, electron gain enthalpy decreases. So much. Okay, right. So electron gain enthalpy decreases. So we expect fluorine to have more electron gain enthalpy than chlorine, right? But this is not true. Chlorine has more electron gain enthalpy than fluorine because of, I think you remember this, inter-electronic repulsion. Okay, it is because of inter-electronic repulsion. What means what? Fluorine is already very small. So if I'm going to trying to add an electron to fluorine, that will repel the incoming electron because of its very small size or high charge density, right? So it is little tough to add electron to fluorine compared to that of chlorine. So that is why chlorine has the highest electron gain enthalpy. Okay, so all the things are correct, right? So there's a mistake in this question, right? So have they given the option as A, the correct answer? People, what is the correct answer given to this question in your answer key? Are you guys there? Hello? Is there a problem? Everybody is there? 21 people I'm seeing. Someone can respond, right? What is the answer given to this question?
So I don't think we have an answer key.
Sorry?
I don't think we have an answer key yet. So
Oh, you don't have the answer key yet? Okay, fine, chill. So this question is wrong. Okay. You will get the marks for this question. All the statements are correct. Okay. So what they could have told is all forms, all can form, instead of monobasic, they can form only one oxyacid. If they tell they all can form only one oxyacid, then that would have been a correct statement. Anyways, but all statements here are true. Okay, fine. Next, of the following hydrides, which can act as a Lewis base? Okay, now I have to turn on my
NH3, sir.
yeah, correct. One second. Let me put this thing in charging laptop. Switched off. Okay, yeah. So which of the following acts as a good Lewis base? Okay. Now, how do we go about this? Now, first of all, we have to know what is a Lewis base. Okay, Lewis base is something which can donate a lone pair. Okay, Lewis base is something which can donate a lone pair. Okay, now all of them have lone pair here, no doubt about this. Okay, all of them can has lone pair here, right? So no problem, right? So if which can easily donate a lone pair is the question, right? All of them have lone pair. Whichever can easily donate the lone pair, that would be a good Lewis base. The correct answer would be, I think, BiH3. Is it not?
Sir, NH3, sir, because the N has a lone pair of electron which can donate electron.
Everything has a lone pair here. All phosphorus, astatine, bismuth, nitrogen, all belong to the same family, nitrogen family.
Sir, it's more electronegative, sir. It's more electronegative and small size.
That's what I'm thinking. If it is more electronegative, right, it would not be able to donate the electron, right? Because this lone pair of electron which is here will be strongly attracted by the nitrogen. Correct? Will be strongly attracted by the nitrogen. So this lone pair cannot be donated because, as you said, nitrogen is highly electronegative, right?
Sir, but NH3 reacts with metals, no, sir. For example, it reacts with copper and donates electrons, sir. But BH3, will it react, sir?
BH3, I know, is acidic. But how do I give a proper explanation is what I'm thinking.
Yes, sir. NH3 reacts with the metal and donates a pair of donates a lone pair of electron, no, sir.
Correct. The other things are not capable of doing that. Okay, fine. But let me clarify this. Okay, we can now fix the correct answer as NH3. But let me check this. I want to check this in Google. PH3, NH3, more basic. Basically NH3, why is NH3 more basic than PH3? Okay, that means definitely NH3 is more basic. Okay, NH3 is a base due to the lone pair of electron and nitrogen available for donation on the PH3 is also, but it's lone. Yeah, go on.
Is it because of hydrogen bonding, sir? Because PH3 is more basic than NH.
Come again.
It can also be the hydrogen bonding.
Hydrogen bonding actually makes sense. Okay, see guys, but we're talking about Lewis base, but so we'll come back to this. Okay, we'll come back to this. I just want to know why is it like this. Basically,
sir, ammonia forms covalent bond, no, sir.
Basic character. One second. Have lone pair which is that are not readily available for donation. Why? And also the pH bonds are weaker, so there's not much compensation for protonating. Okay.
Yes, so the catenation tendency in N is low, no, sir, than P.
Okay. So the correct way to explain this is, right, they're talking about Lewis base. That's the problem. The donation of lone pair, we will not be able to get a proper idea. But what you have to understand is, people say ammonia, if I add H plus to this lone pair can be donated to H plus to form NH4 plus. Okay, now this H plus can be easily attracted by this nitrogen because it is highly electronegative. Right, but if I take, say, PH3, make it react with this thing, for me to form PH4 plus this reaction, I don't even think it will happen. Okay, possible, but it is very tough, right? Why? Because this is less electronegative. Okay, now someone said hydrogen bonding. Okay, it makes sense. Now, how do I do this? Is because now generally, how do I define a base is something which dissolves in water. Right? Once it dissolves in water, it should give me OH minus ions. Then only I will call it as a base. Okay, but we are actually now this, whatever we took here, this is Lowry-Bronsted theory. Right, anything which accepts H plus is what is called as a base. Lewis theory is that one, donating a lone pair, right? And what we're talking about here is Argenius theory. Right, there are three different theories which can explain what is an acid, what is a base. Okay, anyways, Argenius theory says a base is something which when dissolved in water produces OH minus, Okay, now you look at this NH3. If I try to dissolve in water, what will form is NH4OH, and obviously I know this will dissociate to form NH4 plus OH minus. Okay, now this is the property which I'm talking about. Now, if I compare NH3 and pH3, NH3 is more soluble in water than pH3 because of hydrogen bonding. Yes, absolutely. Right? Since ammonia is more soluble in water, so it can easily dissolve in water to give me OH minus. So it can be a better base. pH3 will not even be that much soluble in water. So that cannot give me OH minus. Okay, so either way you speak. Okay, so NH3 will be a good, strong, it will be a stronger base compared to all these things. Okay, NH3 is more soluble in water because of hydrogen bonding. That way you can speak, and so easily it can give me OH minus. Very simple. Okay, next, which of the following is not tetrahedral in shape? It should not be tetrahedral. Okay, now people, the shortest way of doing this is, we know when I have AB4 kind of molecules, they will only be tetrahedral. No lone pair. Okay, only AB4, right? If you have even one lone pair, it's gone. Okay, tetrahedral. Now, we'll look at each and every compound, what is given to us, right? It is NH4 plus, right? That means I have 4 bonding atoms, and since it is a plus, there's a H plus, nitrogen doesn't have a lone pair. So this is AB4, tetrahedral. Okay, next, if I check for SiCl4, right? If I check for SiCl4, right? Silicon has 4 valence electrons and all the electrons are involved in bonding. So again, AB4, tetrahedral, right? SO42 minus, if you draw the structure for SO42 minus, you'll understand. This is how SO42 minus looks. Okay, this is how SO42 minus looks. Now see how many electrons are sharing from sulfur. 1, 2, 3, 4, 5, 6. Sulfur has 6 valence electrons, and all the 6 electrons are involved in bonding here. So again, this is also AB4, that is tetrahedral. Okay, so obviously the answer to this question would be SF4, right? How we'll check. Now in SF4, sulfur has 6 valence electrons. Out of them, 4 are involved in bonding with fluorine. So still 2 electrons are left out. That is 1 lone pair, right? So this belongs to the category of AB4L. Even though there are 4 bonding atoms, there is extra 1 lone pair present. Okay, now this would have actually formed seesaw. Okay, SF4 would have actually formed seesaw shape. Okay, anyways, so it is not tetrahedral. So the correct answer would be B. Okay, next, which of the following reactions of glucose can be explained only by its cyclic structure? Like, I think you attended the class last time, right? So you know that even though it has aldehyde, right, your glucose has a aldehydic group present into it, right? But still, some reactions given by an aldehyde is not given by glucose. Right, one example was your 2,4 DNP test. Okay, one example was your 2,4 DNP test. Okay, 2,4 DNP test was not given by glucose, even though it has aldehyde. Right, so that can be explained only by your cyclic structure. Okay, so I would say the answer to this question is hydroxylamine. Hydroxylamine is like NH2OH. This reaction is not possible. Okay, so you don't know this reaction, right? You don't know aldehydes, ketones, carboxylic acid. So there is no point in me talking about this, right? This is a very, I already told this particular chapter should have come in term 2, right? Because you need to know, what is that? You need to know your aldehydes, ketones, carboxylic acid chapter for you to understand the reactions. Okay, so don't worry about this. Okay, for now you can just, yeah, go on.
Sir, pentacetate of glucose only, it only will not react with hydroxylamine, no, sir. Glucose will react with hydroxylamine, no, sir.
Oh, I am so sorry. Glucose will react, yes, exactly. Pentacetate of glucose will not react with hydroxylamine. Absolutely. Yes, that's the correct answer. Okay. Anyways, you don't have to worry about any of this, right? In the question, like one question will come from the reaction from biomolecules or no question. Mostly in your board exams, right? I really think that questions from reaction part in the biomolecule shouldn't be coming, right? But still, for our safety purposes, you go through the NCERT textbook very properly, especially for the reaction. Other things are very easy in biomolecules. Okay, you do not have to remember the structures also, most probably, right? But at least remember the structure for glucose, at least. That alone, at least you remember. Okay, next. DNA fingerprinting. Right, even though this was not taught to you, I don't know the other sir who taught to you was teaching it in the DNA fingerprinting and all. Okay, DNA fingerprinting, we know, right? What and all we use it for? Determining the paternity of the individual. For example, there is a kid who doesn't know, or say two people, like say there is a lady who got pregnant, okay, and a baby is born, right? And say two guys or two males are claiming that, okay, that is my baby. Okay, that both of them are both the males are claiming that that is my baby. Okay, now how do you confirm who is the guy, who is the father? By taking DNA fingerprinting. I think you would have so many times you've seen in movies, right? Determining the paternity. Paternity means who is the father, right? For a particular baby, for a particular individual. Yes, A can be answered. Okay, next. In forensic laboratories, what do you mean by forensic analysis? Forensic analysis basically, right, when a murder happens, right, and a murder happens, okay, say when the say they will, you would have seen that they will put some powder, dust it, all these things they will do, right? Basically they'll go for fingerprints. They'll take DNA fingerprinting is different from fingerprints. Okay, they would have taken fingerprints, and then how and all can you analyze who is the culprit, who is the murderer. Say for example, in the murder scene, if some hair is found, right, some hair is found, that hair will be taken as a sample. They'll put it in a polythene cover and they will take it for DNA analysis, right? So in the hair you will have your DNA, right? So that DNA will be matched with your person, with the person, and easily that culprit can be found out. Okay, so that is what you mean by in forensic laboratories. There is something called as forensic science, right? A separate branch of science is there. How do you analyze the crime scene, right? Any crime scene, you have a murder or a rape or whatever it is, how do you analyze? That is what is forensic. How do you analyze who's the culprit? What are the evidences you have? That is what is forensic science, and the laboratory which does this is forensic laboratories. Okay, next, to identify racial groups, absolutely, right? See, if I take Indian DNA, all of our Indians will have one DNA, one DNA present. But if I look at an African, right, he will have different kind of DNA, right? See, I am not a racial. I'm not going for racial discrimination here, people. Everybody is same, right? But still, nature is having, say, I don't know. For example, okay, this is a good example. You go for an archaeological site. You know what is an archaeological site, right? They will excavate something from the ground, right? Say you found a human bone. Okay, you found a human bone at some part of the world. Okay, you dug out, right, and you found a human bone, right? You want to know this guy is from which country, or say this guy is an African or a Caucasian or a US or a white or a male or even a Indian or Asian, whatever it is, right? You want to find that out. Now, what will you do? In the bone, if you take, right, if you excavate and take the bone, right, so inside the bone, there is something called as bone marrow. I think biology students might know this, right? There is something called as bone marrow, which is there inside the bone. Okay, now in the bone marrow, right, in the bone marrow, DNA is stored, right? In the bone marrow, DNA is stored. Okay, so now you have excavated, right, and you know that that's a human bone, and you want to identify which part of the world he is from. So you will take the DNA from the bone marrow, right, and then you will analyze it and say, you will check, okay, this is okay. Then it will tell you, okay, this is a African gene, or this is a Asian gene. Gene means DNA, okay, or this is an American gene, something like that, right? So that will be there in the DNA, right? So all of these can be done with the help of DNA fingerprinting. Okay, study more about this. Okay, if you're interested, right? I expect in my PhD, I have a subject itself called forensic science. Very interesting subject. It's like I am Sherlock Holmes. I am solving the crime scene. It's like that. The question paper also will be like that. They will describe a crime scene. Okay, they found knife at this point and it had this blood of A positive, something like that. They will give you, and you have to solve the crime scene. Very interesting subject. Okay, you can even do a degree in this. Okay, BSc in forensic science you can do. Okay, and you can go into any investigation agencies. You can even go into RAW. You know what is RAW? RAW. Anybody knows? In India, what is RAW? Not the WWE RAW. Anybody watches WWE here? Guys, definitely girls will not watch, I guess. Anybody watches WWE here?
Yes, sir.
Okay, great. And I am not talking about that. Okay, that I'm not talking about. This is research and analysis wing, right? How it's a secret agency, spying agency for India. Okay, we go for foreign missions. How your James Bond goes for foreign missions, right? He's a spy. That is for UK. UK has MIB. MI or MIB, something. Okay, something they have. Same way, US has CIA, Central Intelligence Agency, right? So basically, all these are spy agencies of each and every country. Okay, so if you do, basically you'll be a spy. You will be going on these missions if you study for not exactly forensic science, but still, you may if you're an expert, yes, you'll be able to draw. You'll be able to join these forces, RAW or say CBI. What else is there? So many things are there. NIA. Right, all these things you'll be able to join India. Obviously, you cannot join CIA. Right. Anyways, so DNA fingerprinting is used in all of this. Forensic science, in individual paternity, identifying racial groups, all of this. Okay. Next, an alpha helix is a structural feature of easy polypeptides. Yes, right. We know alpha helix, beta pleated sheets, all these things come under the secondary structure of proteins or polypeptides. Okay. Quickly tell me, what is the difference between a polypeptide and a protein? Or when can a polypeptide become a protein? What is the criteria?
So when it has molecular mass more than 10,000 mu and more than 100 polypeptides joined together.
Yes, right. Very good. Very good. So when I have huge molecular mass, when the molecular mass crosses 10,000 AMUs or U, then it becomes a protein. Okay, good, fine. Which carbohydrate is the essential constituent of a plant cell? What is the answer? Quick. What is the answer?
Cellulose.
Yes, cellulose. Now, plant cell has cell wall. Animal cell doesn't have cell wall. Am I correct? Am I right? Biology people, am I right? Plant cell has cell wall. Animal cell doesn't have cell wall. Am I right? Biology. Go on. Is it correct? How many? Any biology student here? I know there are 21 people. Okay. Am I right? Whomever is telling yes. Plant cell has cell wall. Am I right? Okay, good. So plant cell has cell wall, and people, this cell wall is made up of cellulose. Okay, this cell wall is made up of cellulose, and we know cellulose is nothing but a polymer of glucose, right? Okay, polymer of glucose. So definitely it is there. And see, we do now there. I think there is one more question like this. Now, why we cannot directly eat grass? Right? Animals can eat grass, right? You say a cow can easily eat grass, right? But can I go and eat grass just like that? I pick it and I eat, I put it in my mouth. Is it fine? Or obviously we'll not like it, but can it get digested in our body? Is the question. The answer is no. Why? Because this cellulose cannot be digested in our body. Okay, cannot be digested in human body, I will tell. Why? Because we do not have enzymes. There are no enzymes which can break cellulose. No enzyme in our body can break cellulose. That is the reason. Okay, we don't have the proper enzymes to break cellulose into glucose. But when you have starch, yes, starch is also a polymer of glucose, but we do have enzymes for this in our body. Okay, some enzymes are there that can break up starch into glucose units, and that can be utilized in our body. Okay, but we don't have enzymes for cellulose, so that is why we cannot eat grass. We are not animals, right? We are a little more sophisticated, so we eat starch. both are glucose, but see how amazing it is, right? Both are glucose, but certain enzymes cannot digest glucose. Sorry, cellulose, but some our body enzymes can say some enzymes can break up starch. Okay, fine. Next, which of the following is not present in DNA? What is the answer? Quick, people.
Uracil.
Uracil.
Sir.
You know, uracil present in RNA, right? Adenine, guanine, cytosine, all are present in DNA. Uracil is present in RNA. Okay, good. Next, when a nucleoside is linked to phosphoric acid, what do you get? Quick, what is the answer?
Nucleotide.
Nucleotide, right? When you have the base plus the sugar, this is my nucleoside. Okay, now to this, if I add your phosphorus, then it becomes a nucleotide. Okay, fine, it becomes a nucleotide. Okay, so the correct answer is this, nucleotide. Okay, going on. Which one given below is a non-reducing sugar? Quick, what is the answer?
Sucrose.
Yes, sucrose. Because sucrose doesn't have the hemiacetal. I told you how to decide whether it's a reducing or non-reducing sugar. You have to look into whether I have a hemiacetal present or not. I know hemiacetal is one OH and one OR in the same carbon. This is what is hemiacetal. If you find that in the cyclic structure, then you are ready for deciding whether it's a reducing or non-reducing sugar. What is the time, people? I should not be wasting time. Half an hour is there. Okay, next. The biological polymer is what? Quick, what is the answer? Biological polymer. That means in nature it exists. We don't have to prepare it. What is the answer?
Nucleic acid.
Nucleic acid. This is my DNA, RNA. Right? These are naturally occurring polymers. Right? Steric acid is not even a polymer. Palmitic acid is not a polymer. Formic acid, I know, is just HCOOH. Right? None of them is first of all a polymer. Right? And obviously nucleic acid is a biological polymer because it is inside our body. It is produced by nature. Okay, next. Which of the following is an oligosaccharide?
Sucrose.
Okay. Oligosaccharide is basically two or more monosaccharides, right? I know in sucrose, I have two monosaccharides, that is glucose and fructose. So sucrose is the correct answer to this question. Okay, next. Which of the following statements is not true regarding glucose? It does not give 2,4 DNP. Correct, right? That is why we go for cyclic structures. It does not give 2,4 DNP, so this is correct. It is an aldohexose. Yes, it has 6 carbons and it has the CHO. So aldohexose. Fine. It is present in furanose form. Huh? No, it is present in pyranose form. Only for fructose we say furanose. For glucose we talk about pyranose. So this is not correct. So the correct answer to this question is option C, which is present in furanose form, which is not correct. Okay, next. The sugar constituent of DNA. Quick, what is the answer?
D2-deoxyribose.
Deoxyribose. You forget about D2 and all. It is deoxyribose is the answer. For RNA, it is ribose. Very simple. Okay, next. Which of the following polymer is stored in the liver of animals? Liver of animals?
Glycogen.
Okay, I don't know. Okay, I really don't know this question. Check this out. Okay, these are all biology questions. I don't know why are they asking in chemistry. Anyways, okay, fine. Moving on. Ozone can be detected using what? I think it is Ki, right?
Yes, sir.
Yeah, I think it is Ki. Okay, fine. You look at the reaction in the textbook. Okay, fine. Next. Which one of the following is the correct order of bond dissociation enthalpy of molecules? Now, please understand, people. Bond strength is directly proportional to bond enthalpy. We all know bond enthalpy is the energy required to break the bond. Okay, so stronger bond requires more energy, right? That we know. Understood. Okay, now how do you decide the bond strength? Okay, bond strength is inversely proportional to the size. That means smaller atoms forms stronger bonds. That's what I'm trying to say. Okay, smaller atoms forms stronger bond. As simple as that. Smaller the atom, stronger the bond. So I know FCl, Br, I2, F is the smallest, I is the biggest. So this would be the answer to this question. Okay, Smaller size, more strength. More bond strength, more enthalpy, more energy of the supply. So very simple. Am I doing it correctly? Yeah, this is the answer. Yes. Okay. Next. In XeO3 and XeF6, the oxidation state of ion is very simple. This is, you can calculate XeO3 X minus 6 equal to 0. Minus 6, how it came? For 1 oxygen minus 2. So 3 oxygens minus 6. So X is plus 6. XeF6. Right now you see that this will be X again. For 1 fluorine it is minus 1, so 6 fluorine minus 6, so plus 6 and plus 6. B is the answer. Next question. Which of the following elements do not show allotropy? Which one? Which one? Quick.
Nitrogen.
Nitrogen. Any element, right? Nitrogen is nitrogen. Is it correct? Yeah, nitrogen only. Yes, this cannot show allotropy. Allotropy means what? Different. Same element but in different physical forms. Like say for carbon can be graphite, carbon can be diamond, carbon can be Buckminster fluorines, right? Same way for phosphorus also, for white phosphorus, red phosphorus, black phosphorus, right? But nitrogen doesn't have anything like that. Okay, nitrogen doesn't.
Sir?
So yeah, go on.
So for the 27th question, is the answer the D, sir? D should know, sir.
Cl2, Br2, F2 and I2. Okay, it does
Sir,
make sense.
Sir,
yes,
because fluorine is very small in size and it's the most high electronegative atom, sir. So therefore, bond will break, no, sir.
No. What you have to understand is, if I check an FF bond, okay, now you see that both the fluorine atoms are very small and there is already 3 lone pairs present. Okay, 3 lone pairs present. So I can have a repulsion between these lone pairs. Okay, since fluorine is very small, these electrons are very close by, so I can have repulsion between them, right? So yeah, that makes the bond weaker. Absolutely. Okay, that makes the bond weaker. Okay, so I think for chlorine and bromine, this is okay because the size is little bigger, the electrons are a little far away, so it's fine. They will not undergo that much repulsion. So yeah, I think the correct answer would be D. Okay, correct answer would be D. But in general, this is what you have to understand. Okay, now why between chlorine and bromine I have a different thing? Because chlorine is smaller, so stronger bond. Br is little bigger, so weaker bond. Same goes with I2, the weakest, right? But fluorine alone is making an assumption here because of its very small size. Very small size, though I can have repulsion between the electron. Though that means the 2 fluorine atoms will try to go far away. That means the bond can be easily broken. Okay, so good one. Thank you. Right, the answer would be D, not B. Okay, moving on. Hydrolysis of 1 mole of peroxodisulfuric acid. Okay, peroxodisulfuric acid. Formula would be, I think if I can write the structure, I think it will be useful, right? I need to have a peroxide linkage. Okay, this is what is, I don't know the formula, but I know this is the structure. I need to have a peroxide and I need to have 2 sulfuric acid, kind of 2 sulfur should be there. This is the structure. Okay, so now when I go for hydrolysis, people, I will break this peroxide bond. So what will happen? This will become, I think, sulfuric acid, right? This will become what? H2, no, first of all, 1, 2, 3, 4, 5. Only 5 bonds are there. That means it is wrong. So this is not OH. Right, this should be double bond O. Same way, this is not OH. This is also double bond O. Yeah, now when I break this bond, you can easily understand that I would have gotten S double bond O, OH, another OH, and OH here. H and H you put it here. Very simple, right? So I would have formed 2 moles of what? This is sulfuric acid, right? H2SO4. Okay, so the correct answer would be 2 moles of sulfuric acid would have been formed. Very simple. All you have to know is the structure and break it in between and put H both sides. You are going to end up with sulfuric acid. Okay, next. Which gas is evolved when urea NH2CO NH2? This is what is urea. We treat it with NaOH. Okay, so definitely the answer is going to be ammonia. Ammonia NH3 will be the one. Okay, you can, even though you don't know the reaction, I'm just looking at the structure and guessing the answers. Okay, NH2 is there, so it can easily form NH. NH2 is there, it can easily form NH3. So ammonia should be the proper answer. Okay, next. Which of the following oxides reacts with both HCl and NaOH? Means they're asking about amphoteric nature. Okay, AMPHO, amphoteric nature. Okay, now I know only two of the elements can form amphoteric compounds. One is zinc, another is aluminium. Okay, mostly all the compounds formed by zinc and aluminium are amphoteric in nature. That means they can react with an acid, they can react with the base. That is what is by HCl and NaOH. I know HCl is an acid, NaOH is a base. So the answer to this question is I don't know, because this is where you have zinc. Right? All the others will either be acidic or basic oxides. Okay, right? So the answer is I don't know, because only zinc and aluminium can form amphoteric oxides. Okay, next. Which of the following is thermally most stable? I think I've already answered this question. H2O is the maximum stable because it has the highest bond strength or highest bond enthalpy. Okay, next. Which of the following will act as the strongest reducing agent? Right, now this is coming from inert pair effect. What is inert pair effect? Stability of higher oxidation state decreases down the group. Right, stability of higher oxidation state decreases down the group. Right, now you see that this is +3, all of them are in +3 oxidation state, that is lower oxidation state, right? Okay, lower oxidation state, stability, higher oxidation state stability increases. Oh, one second.
The reducing will decrease, no sir, down the group. So sorry,
Yeah,
sir, it will increase down the group,
higher
sir.
oxidation state decreases down the group. Correct. Yes, that's what I'm telling. That I
No
don't
sir,
correct.
reducing will increase, no sir, down the group. Reducing property will increase, no sir, down the group.
Yeah, that is fine. We have to, how reducing property decreases, we have to talk in terms of oxidation states only. Okay, anyways, so this is what I have, right? That means I can write the other way around. Stability of lower oxidation state, right, increases down the group. Okay, lower oxidation state increases down the group. That is what is inert pair effect. Okay, now you see all of them are in +3, right? Now if stability increases, one second here.
Sir?
Yeah.
Sir, we know that the thermal stability decreases down the group, no sir.
Okay. We cannot speak like that, Kana. See, for reducing agent, right, it has to undergo oxidation. That's what you have to understand.
Sir, no sir, but we can say that thermal stability decreases down the group, sir. Therefore, the bond length will increase and the bond strength will decrease down the group. So we can easily break the bond between SB and H, sir.
Okay.
Therefore, we can evolve hydrogen gas, no sir.
Yes. Makes sense. Okay, that is also a good way of speaking, right? What is he telling is when I go down the group, the bond strength decreases. Obviously, NH bond is the strongest, and I think ASH bond is the weakest. Right. So what I have to do, I like for it to be a reducing agent, this hydrogen has to be added to something else, right? So I should be able to easily break the bond, right? So definitely easily I can break the bond only in ASH3. So the correct answer would be
SBH3, sir.
Oh, after ASH, SB comes.
After AS only SB comes.
Then SBH3. Yeah. Okay. Right. Next question. What is the time, people? Okay, 15 more minutes. Okay. Which of the following below is incorrect? O3 molecule is bent. Yes, it is bent. You would have known the structure by this time, I guess, right? Right. This is bent. This is how the structure of ozone is. Okay. ONF is isoelectronic with NO2 minus. I think they are mentioning NO2 minus is what they're asking here. Okay, it says a printing mistake. Okay, and just check the number of electrons in here. So oxygen has I think 8 atomic number. This has 7. This has 9. Right. So 8 plus 7 is 15. 15 plus 9 is 24. And here NO2 minus NO2. Nitrogen has 7. Oxygen has 8 into 2 will become 16, and I have one negative charge, so +1 electron extra. So 17 plus 3, 24, 23, 24 again. Okay, so they are isoelectronic. Okay, what do you mean by isoelectronic? Same number of electrons. Okay, same number of here I have totally 24 electron, here also 24 electrons, so they are isoelectronic. Okay, OF2 is an oxide of fluorine. No, please understand, oxide means I need to have O2 minus. Okay, oxide means I need to have O2 minus. Now I know oxygen is in +2 oxidation state here. It's not minus. Fluorine is more electronegative. So what you can call is, it is an fluoride of oxygen. This is how you can call, not oxide of fluorine, right? It is fluoride of oxygen. Okay, because fluoride is F minus. That I know. That is what is exactly here. Fluorine is in -1 oxygen state. But oxygen should, if at all it is an oxide, oxygen should be in -2 oxygen state. But no, here it is in +2. So this is the incorrect statement. So C is the correct answer. Okay, next. Which of the following molecules, all the bonds are not equal? Okay, now not equal. Now you have to check. NF3 will be fine. This is pyramidal. BF3 will be fine. ALF3 is fine. The answer would be CLF3. Now why CLF3? Let me tell you. Okay, now CLF3. Now Cl has 7 valence electrons. Out of them, 3 are involved in bonding. So I have 4 more electrons left out. So 2 lone pairs. Right. So this is of the category AB3L2. Okay. So if you had had AB5, that is all 5 bonding atoms, I know I would have had a structure like this. Right. And this is my trigonal bipyramidal. Now these 3 bonds are what are called as equatorial bonds. Right. And these 2 are what are called as axial bonds, and these 2 bond lengths are different. Okay, so CLF3 also will have the same geometry because it has 5 steric number. So definitely you say that axial and equatorial are present. So definitely it will be, they will have different bond lengths. Okay, so CLF3 is the answer to this question. Okay, moving on. In DNA, the linkages between different nitrogenous bases are what? Quick, what is the answer?
Hydrogen.
Yes, right. Between different nitrogen, I'm talking about base and base. Adenine, guanine. Hydrogen bonding. Adenine, thymine, right? They will have hydrogen. I told you how they form the duplex or say double helix, right? 1 helix, 2nd helix, hydrogen bonding. That is how they do together. Okay, good. Hydrogen bonding is the answer to this question. Moving on. The statement about denaturation is given below. Okay. Denaturation of protein causes the loss of secondary and tertiary structure. Yes, right. Please understand, denaturation does not affect primary structures. Does not affect primary. Okay. Now, denaturation leads to the conversion of double stranded DNA to a single strand. Yes, definitely. Right. Denaturation means like it is not in good state. Right. So a double stranded DNA will become a single stranded DNA. Yes. Okay. Denaturation affects the primary structure. No, this is not correct. Okay. So only 1 and 2 are correct. So option is C. Next. Hydrogen bond and peptide linkages. Okay. Hydrogen bond and peptide, both should be present. Okay. Hydrogen bond and peptide linkages are present in what?
Primary, sir.
No, primary has only peptide, right?
Sir, but the peptide bonds are linked with hydrogen bonding or no, sir?
No. Peptide is an amide bond. This is a proper chemical bond. We know C double bond O NH. Right? This is my peptide bond. Okay. So this question is wrong. Okay, because quaternary, secondary, and tertiary structures, all of them have both hydrogen and the peptide linkages. Okay, this structure is wrong. I mean, the question is wrong. Okay. Because quaternary, secondary, and primary all can be answers because all of them contains hydrogen bonding as well as peptide linkages. Okay, I asked them to change this question. I don't know why they didn't change. Okay, fine. I asked them to change 16, 17, 18. 16, 17, 18, what we had? There is a question paper. Okay, 16, 17, 18, they changed. Right, but 39, they forgot to change, I guess. Okay. Fine. Anyways, next, an amino acid is very simple. Amino acid should be a same carbon having NH2 and COOH, and that is right there in option A. CH2, NH2. This is my glycine, right? A famous one. The glycine. This is only COOH. NH2 is not there. This is not even. This is ammonium ion. NH4 plus is there. This is not. And OH and COOH no. So the correct answer would be NH2, CH2, COOH. Amino acid. Okay. Peptide linkages are present. Very simple. Proteins. Right. Okay. Next. I asked them to remove this also. Okay. Fructose reduces tolerance reagent due to. Okay. I will teach you some other day. So it is because of enolization of fructose. You don't even know what is enolization. That is why I'm not teaching this. Okay. You don't even know what is enolization, but the correct answer is D. Okay. Fructose, generally tolerance is given only by aldehyde. Okay. Fructose has a ketone. Okay. But somehow ketone is also giving me a tolerance test. Sorry, in case of fructose. Okay. Next. Okay. Next. In the following disaccharides, if the reducing groups are monosaccharide, ketonic groups are bonded, these are reducing sugars. Forget about it, right? Which of the following disaccharide is a non-reducing sugar? Now we know what I have to look for. I have to look for hemiacetal. Okay. Now, if a hemiacetal is present, it is going to be a reducing sugar. If it is not present, a non-reducing sugar. Okay. Now look at this. For example, option B. This particular carbon. Okay, this particular carbon has a OH, and you see it is having a OR, so it will be a reducing sugar. Okay. Same way, you check for this carbon, right? OH and OR. Fine. Same way, for this carbon, OH and OR, hemiacetal is there. But check for either any other carbon having here, is anything having like this, hemiacetal, you will not have anything. Okay. If you check for this carbon on this particular carbon, it is having a OR, but there is no OH. Okay. So the non-reducing sugar is option A. I hope everybody gets this. How am I doing this? All you have to look for is one carbon having OH and O, something with this, something like some another carbon. That's what I'm looking for. This is a hemiacetal. Right? Okay. Moving on. Quick. The carbohydrate which cannot be hydrolyzed in the human digestive system. That's now we spoke before this, right? We will not be able to eat grass or plants directly because we cannot digest cellulose. That is the answer. All the other things are fine. This is milk. Yeah, I know we eat milk. This is your normal food. Maltose is also sometimes present in milk. Okay, that is also a sugar anyways, right? Fine. Which of the following is a fibrous protein? Okay, again, fine. Fibrous protein would be, I think, not glycoprotein, not protease, keratin. Yeah, keratin is the fibrous protein. Okay, fibrous protein means it. We don't have to go into the details. Okay, we don't have time for this, right? Just know this. Okay, fibrous protein is keratin. Okay, next. Association reason. Among the nitrogen halides NX3, the dipole moment is highest for Ni3 and lowest for NF3. Yes, absolutely. Now you see, I have Ni bond, I have NF bond. It is all about difference in electronegativity. Okay, more difference in electronegativity, more dipole moment. Okay, more difference. Now you see, fluorine is highly electronegative. This thing is okay electronegative. There is very less difference in electronegativity. But iodine is less electronegative, and this is more electronegative. There is more difference in electronegativity. Okay, so the assertion is right. Right, among the NX3, Ni3 will have the highest dipole moment, NF3 will have the lowest dipole moment. Okay, now look at this. Nitrogen halides NX3 have a trigonal pyramidal structure. Okay, the statement is correct. Okay, it's like NH3. I know NH3 is going to have pyramidal, NH. This is how the shape looks. Okay, this is pyramidal, trigonal pyramidal, but that is not the correct explanation. The correct explanation is because of difference in electronegativity. Okay, so both assertion and reason are correct, but it is not the correct explanation. So B is the correct answer. What is the time? Okay, 5 more minutes. Right. Next question. Iodine dissolves in aqueous solution of potassium iodide. Why? Okay, basically I2 can react with Ki to form I3 minus Ki3 basically. I can write it as Ki3. Okay, this is possible. Okay, fine. Why? Potassium iodide behaves as an organic solvent. How is it an organic solvent and therefore dissolves a non-polar iodine? No. Why it happens is because my I minus can act, still it has empty shells. Okay, it has empty shells. So it can accommodate one more I minus. It can accept the electrons from I minus to form I3 minus. Okay, that is the reason. So first one is, this is correct. This is not even a correct. This is because potassium iodide is not an organic solvent. It is a normal inorganic solvent. Okay, so A is true, but R is false is correct. Next, N2 is less reactive than P4. Yes, definitely, because I know it is N triple bond N and it is P single bond P, wherever it is, if you see P4. Okay, nitrogen has more electron gain enthalpy than phosphorus. This is a wrong statement. Phosphorus has more electron enthalpy than nitrogen. We have already seen this. FCl, Cl has more. Oxygen, sulfur, sulfur has more. Why? Again, all of this is because of inter-electronic repulsions, right? When the electron is added, because of small size, you will have repulsions. Anyways, so this is not even correct. Okay, this is correct. N2 is less reactive than P4 is correct. Okay, so option C is the correct answer. A is true, but R is false. Okay, next. Complete hydrolysis of RNA. Okay, complete hydrolysis of RNA will yield what? Yeah, definitely nitrogenous base. Phosphoric acid, I know. Pentose sugar will be there. So all of these will be the answer. Okay, next. Each polypeptide in the protein has an amino acid linked with each other in a specific sequence. Specific sequence. This sequence of amino acid is what is called as primary. Because in primary, we just talk about what is the sequence of amino acid. Okay, and in secondary, tertiary, and quaternary structure, how the protein folds, how the primary structure folds to bring this complicated structure. We saw the complicated structures in the class, right? So how is it? That is different. So the answer to this is primary. Okay, hemoglobin. Hemoglobin is a protein. Okay, hemoglobin is present in your blood, is a protein, globular protein. Don't worry about it. It's a protein. That's all you have to understand. Okay, next. Okay, now I think this is Haber's process. I think you'll be able to answer very easily, right? You just look into the Haber's process, right? And you'll be able to, yeah, go on.
Sir, hemoglobin is an enzyme, no, sir?
No. Hemoglobin is a protein. Okay, hemoglobin is, see, what is an enzyme? You understand? Enzyme should be a catalyst. Right? Say, for example, I have starch. Okay, starch is basically glucose, right? Starch is so many number of units of glucose, NC6H12O6. Okay, this is starch. Okay, now this starch will be converted into glucose in your cell, and this reaction is catalyzed by an enzyme. Okay, so what you have to understand is enzymes are biological catalysts. Okay, enzymes are biological catalysts. Okay, so don't worry about it. Enzymes are not the answer here. Hemoglobin is just a globular protein which carries blood. That's it, right? I would say which carries oxygen in the blood. Okay, right? Fine. We will spend some time on this. Okay, once we get time, once you have Friday and the Saturday class, Friday and the Sunday class, we'll discuss more about this. Okay, now we don't have time. I think now everybody will be able to easily answer these questions once you study Haber's process. Okay, and you can easily study this and just get to know. These kind of questions are very rare. Okay, and the numbers, you really don't have to remember this. Okay, I think the number is 300 here. Okay, like that.
200, sir.
200. See, that's the problem. This kind of question should not be asked. Okay, but if the question paper setter is, I don't know, really want to make you suffer, then yeah, he can. Right. So anyways, you can answer these questions very easily. Ammonia has how many bond pairs, how many lone pairs? See, you have 3 NH bonds. So 3 bond pairs, right? And there is a lone pair on nitrogen. So 3 bond pair and 1 lone pair. C is the answer to this question. Okay, so like this, you can easily answer all of these questions. Okay, so any other question?
Sir,
yeah,
50 second alone, can you say the answer, sir?
50 second. On a small scale, ammonia is obtained from ammonium salts which decompose when treated with, I think NaOH, sodium hydroxide. So you saw, right, when I have, sodium hydroxide from ammonium salts. For example, if I had NH4Cl, if I make it react with NaOH, what will happen? I will have NaCl plus NH4OH, and NH4OH will, from this I can remove a water molecule to form NH3. Yeah, it is NaOH. Okay, sodium hydroxide. Okay.
Sir, but in the textbook it is calcium chloride, sir.
Calcium chloride. How calcium chloride? Say we'll check. Say NH4NO3 plus calcium chloride will give me what? NH4Cl plus CaNO3 twice. How from this I'll get ammonia? I'm not sure. Okay, please check this. Okay, I'm not sure about this. Right. See, even though a scientist is there, you know, a brilliant chemist is there, these kind of things, remembering those many reactions, anything without a logic, remembering is very difficult. Okay, this doesn't have any logic, these kind of reactions. Okay, that is why it is very tough to remember. Okay, whatever you find in the book, whatever is your answer, you can click this. Okay, if it's calcium chloride, then calcium chloride, sodium hydroxide. But at least sodium hydroxide makes sense to me. Okay, I don't know how calcium chloride can be the answer. Fine. Okay. Any other questions anybody has? Something there's the chat. Yes, sir. Animal cell lacks cell wall. Yes, good. Okay, so I'll stop right here, people. Right. I hope, even though I went a little fast, I hope everybody was able to follow whatever I was teaching. Okay. Thank you so much, people. We'll meet again next week. I'm stopping the class.
Thank you, sir.
Thank you.
Thank you, everybody. Thank you.